Isn't that open? All right, so this one says a sociologist thinks that middle school boys spend less time studying in 1981 than middle school boys do today. So the study conducted in 1981 to find the time that middle school boys spent studying on weekdays. The results are shown for 1981 and for today. So this first column are the 1981 results. Second column is today's results. Okay, so we have two situations. They're independent. You couldn't have been a middle schooler in 81 and a middle schooler in 2021. Okay, so we know they're independent. The populations are normal that they come from. So this is a situation where we can use the Z distribution. What we like to do, or what we need to do, is construct the hypotheses for this. Okay, so there we go. When we say H sub 0 and H sub A, okay, so the sociologist thinks that middle school boys spend less time studying in 1981. So they spend less time in 1981 than they do now. So that is, because it says less, that is not equality, right? Okay, so our assumption is that they should be from 1981, which we'll call that mu sub 1, and today, which we'll say mu sub 2. The assumption is that they're the same. He claims that 1981 spent less than mu 2. Does that make sense? Okay. And if you're a person that wants to stay consistent with the complement concept, if you want to add the greater than symbol there so that they are complements, you can do that. Okay. Now, which one's the claim from this statement here? Bottom one's the claim. Okay. And we don't have an alpha here. Let's just use the same alpha the textbook I got this out of uses. Let's use alpha to be 2.5%. Okay. Now, what kind of test would this be? Because of that symbol there. It's a left-tailed test. And that's important because of what is going to be provided for us in our table when we process this all in Excel. So now what I want to do is I want us to grab these, just highlight these. They're in tables, but you don't see the table until you highlight it. Highlight those, and then right-click, copy. Then you can jump over to Excel, and then just click in A1, and right-click, and paste. Are we okay with that? Okay. Now, we need, in order to conduct this test, we're going to need the variance of both of these. So I'm just going to say, I'm just going to put a label here that this is going to be variance of 1981, and then variance 2021, and then underneath, just calculate those variances. So are these samples here, or are they populations? Samples. So I'm going to hit equals var dot s for sample, and I'm just going to say A to A. Okay. Now I just got to be cautious when I use A to A that I don't have anything else in that column, any like lingering values down below, because if you look at this, what it does is it highlights the entire column, right? So if I was doing this inside maybe another workbook or another sheet in which I had stuff down here for something else, I would want to make sure that I don't include that. So if you're just going to leave this as a raw data column, then there's nothing wrong with saying A to A, because when it sees a empty cell, it will realize that it's not supposed to incorporate that. Does that make sense? Okay. There are commands in Excel when it sees an empty cell, it views that empty cell as a 0. Variance is not one of those. Okay, so hit enter, and we get our variance. Okay. If you had that issue, if you're worried about whether empty cells matter or not, okay, then you're just going to select and go to B, in this case, B1, and go all the way down to my last value in 35, so B35. Close it off like that, and it will do the same thing for us. Okay. Now, yesterday we talked about, because we're going to type that number in, and it's better for us if those numbers, the more decimal places that we have, the more accurate our test is going to be. So it makes sense to extend or expand the size of your cells so that it incorporates a more precise variance for us. Okay? Is that all right? That's all we have. That's all the calculations that we have to really do. Everything else we have to tell basically Excel where to look and where to gather information so that it can do now calculations. So what you're going to do now is you're going to go up to data. Okay, go up to data. And if I go over to the right here, it says data analysis. Did everybody's data analysis load still? Okay. So we're going to click on data analysis. Get this pop-up window. Okay, and the one that we want for the differences of means is all the way at the bottom. It's the last one. Z-test says to sample for means. Click on that. Click OK. And now we have to identify what our variables are. Okay, so it says variable 1, range. That means where is your data for the variable 1, which was the 1981 study. So I'm going to click on this box here. Okay, and get my cursor in that first box, and then I can just go highlight that column. And it automatically, I wish you could zoom in on this box and you guys can see a little bit better on my screen, but it automatically uses the correct notation to reference that data. Okay? So okay with everybody? And it puts these dollar signs on it so that those values stay static. That if we were doing anything else that makes things move around in this sheet, that calculation doesn't change. Yeah, do you remember how to go through that? Okay, so variable 2. Variable 2 is referring to the data in 2021, so that's our second column of data. Okay, so we select that. The hypothesized mean difference, that's going to be 0. Okay, it's always going to be 0 for us. Now it says variable 1 variance, so it has to be the variance, and this is why I label things. I want to make sure that it's the variance that attaches to variable 1, right? Okay, so I got to type that number, and I messed around with this yesterday. I can't figure out a way that will let me reference a cell here for whatever reason. So they make you type this number in. So 20.045344454. And then variable 2 variance, this one right here, 21.63398.319. Okay. We want an alpha of 0.025. This box, this labels box, what that does is if I were to have selected column A, if I would have put maybe a label on column A, like column A is data from 1981, and then in this cell I put data from 2021, and I selected the entire column A to A and the entire column B to B, if I click that box that says labels, it would recognize those strings, which are basically characters, or words or labels, and it would remove them from the calculations. Does that make sense? Okay. But since we don't have labels, we didn't do that. We don't need to check that box. We'll click on the output range, okay, and just click a box where you want that, okay, or you can just type in the cell that you want to put it in. You can even, now there's other things there. It says new worksheet. I don't know, apply. I don't know if I'm just going to bring up a new sheet. A new workbook will open another iteration, another process of Excel. But let's just go ahead and put output range, and it'll put it on the sheet that you're on. Just click that box there, and then click where you want it. And if you hit OK, it then does everything for us. Okay. Now I'm going to widen these cells. Okay. And what we see here, okay, now we ran through our data. Okay, so it gives us the mean, it gives us the variances, or we type the variances in. So it did this by itself. It calculated how many samples we had, or how many objects we had in our sample. Here it did the z-score. So it did the x bar sub 1 minus x bar sub 2 minus mu sub 1 minus mu sub 2 all over the square root of variance 1 divided by n1 plus variance 2 divided by n2. It did all that, okay? And it calculates it to be negative 14.17. That's my z for my data, okay? It even, because of the alpha that we chose, it tells us what the critical values are if it's a one-tail test, and it tells us the critical values if it's a two-tail test. Does that make sense? Okay. Now, what we have to do to pay attention to this and to get the correct answer is we still have to have a knowledge. We don't necessarily need to draw it, but I think that's helpful. That if it's a left-tailed test, okay, and that's what we had, it says a critical value right now of a one-tail. It doesn't say one-tail right or one-tail left, but it gives a positive number back, right? But because this thing is symmetric, we know that this 1.96, if it was a right-tail test, it would be 1.96. But it's a left-tail test, so what number is this really? Negative 1.96, okay? And our area would be there, right? Okay. Now, the z that we have is negative 14, which is all the way over here, right? Okay. So that's obvious, hopefully, that we would reject h sub 0. Is that okay? Okay. Now, and here's the thing. Think about how this thing, this area gets very, very small. We got the beyond 3 standard deviations, that area is very marginal, okay? So we're all the way up to negative 14 standard deviations. So they are saying that the area is so small that the p-value is 0, okay? Well, if my p-value is 0, think about looking at it this way. P-value compared to alpha value, p-value is 0, alpha is 0.025. It's really, theoretically, it's not 0. If we were to really look at things and get it'd be probably like point and maybe a very large series of zeros, but then a non-zero number after that. So it's like 0.000000000 something, okay? But regardless, is the p-value less than alpha in this case? P-value is less than alpha, we reject the null hypothesis. Okay, so if we go back to our scenario, look at our hypotheses that we wrote out, we're going to reject this, reject the null hypothesis. Okay, so that means that's not true, and it leaves us with evidence to support the alternative hypothesis, right? So we now have evidence that says this sociologist's claim is accurate. Okay, so we would say we reject the null hypothesis. There is sufficient evidence to support the claim that middle school students in 1981 spent less time studying than middle school students in 2021. Does that kind of make sense? Okay. Now these values, and I'm just pulling these from a textbook. A lot of times when you run this, these numbers of 0 are not always going to be 0. They may be p-values that are non-zero values, which would make sense maybe based on some of the stuff that we've been doing by hand. So just be on look at those aren't always zeros. The one we did yesterday, if we would have gotten the one yesterday done correctly and put the data in columns, the z becomes like positive 64. So you're 64 standard deviations to the right, and again, that would give you a p-value of 0. Okay. Is it okay with everybody? Yes, please. I think we should. Then don't worry about the track meet. Okay, so now let's run through the other scenario. Down here says a sociologist claims that children ages 6 to 17 spent more time watching television in 1981 than children ages 6 to 17 do today. Study conducted in 1981. Find the time that children spent watching television on weekdays is shown. That's column 1. And the data for today is in column 2. Okay. So we want to first determine our hypotheses. Why don't you guys take a minute and write your hypotheses. And there, in your homework, there should be a button that you can, when you open the raw data, it pops open in a table, and you can click that button, and it'll put it on your clipboard, and you can merge that over to Excel. So, you guys agree with these hypotheses? We're going to assume that they are equal. Okay, the populations are equal. And I put less than or equal to just to stay with the idea of complements between what the alternative hypothesis, which was the claim, said. It said it spent more time in 81 watching TV than today. So 1981 being mu1, today being mu2, so mu1 greater than mu2. Right. If you wanted to leave this just as equals, that's fine. Now we're going to grab that data. We're going to paste it into Excel. Now, I don't know how this will work. That's what I wanted to see. Yep, it appears that way. What Blaze was asking was, does that, when I plug in new data, I deleted column A and column B from the previous question, and I put in our new data. If you see that, what happened was that the variations changed, or the variances, sorry, they changed, because those were written, we put formulas in those that were based on what was in A and B, right? The table does not change. So the table is static. So it makes sense that I'm just going to go ahead and highlight that and delete it the best I can. I don't know how. I was messing around with this yesterday. The formatting, when you delete it, goes away, or doesn't go away. So these lines, but these lines are just like they're just highlighting the border of those cells. So if you go find, if you want those gone, go to Home, maybe, or Insert. You might be able to right click. I don't know. See where it says border here, border. And I click on there and come down here and say no border, and now they go away. Doesn't matter. Now that I got that data put in, we know the variance is calculating there. Here, the variance is calculating there. Let's go ahead and go up to data analysis again. Go down to the last one, hit OK. All right, now I'm going to collect my, it automatically put in stuff, the last information I had. Well, if I click on that, you see how when I click here, or click there, you see how it toggles back and forth with that dotted outline on the data? See that? Okay. So when I click here, I can either select that data again or just know, hey, that works. That's fine. I'm okay with that. Okay. That range there, I'm fine with that. Okay. If you want to shorten it up to 30, you can. Okay. B1 to B30, that's fine. And then A1 to A30, that's fine. Yes, boys. You can do A to A, B to B. So if I type this in, A, B, B, that should be appropriate. Okay. Now I hit enter on accident, and I shouldn't have. So it calculated everything up with the wrong variances in there. So let's go back. So if you want to go A to A, B to B, that's fine. Hypothesized mean 0. Now we got to type in our standard our variances. So 0.2401034448, and the next one is 0.22116092. Let's use alpha as 5%. I didn't say it in the problem, but let's just go 5% for alpha. In my output, I'll just leave my output range where it was. And I'm going to hit OK. Output range will overwrite existing data. Press OK to overwrite data in range D. Yeah, I'm OK with that. So basically, it's saying I never deleted this out there. So it's going to override what's in there. I'm fine with that. And we should get something like that. Okay. So now in this situation, we get a z-score of 3. Okay. Now this is when we did our hypotheses, remember our hypotheses was not that one. It was a right tail test, right? Okay. So when we draw our normal curve, okay, there's that. We got a critical value, okay, it's a one-tail test, critical value of 1.64. So 1.64 is there. So this is our rejection region, okay. They are showing that our Z was 3.01. So 3.01 would be over here to the right, correct? In the rejection region. So we reject H sub 0 based on our Z comparing it to our critical value, okay? Or we could say we're going to take the p-value right here, okay? That p-value of 0.0013 and compare it to our alpha. We said alpha was 0.05. Is the p-value less than the alpha? Yeah. In that condition, if it's less than, you also reject the null hypothesis. So they're giving you all the information you need for both techniques, for both methods of making the decision, either whether you use your critical values or if you want to use p-values. Not all statistical packages do that. IBM has a statistical package called SPSS. Yep. Is it International Business Machine? I think that's what it stands for. Computers. IBM's. So if I'm just going to open this up, but does that look structurally kind of like Excel? Excel does more things outside of statistics than what this is. This is solely dedicated to stats. I don't know this very well. So, like, I've used it in the past when I was in, doing Like when I had to write my master's or do my thesis for my master's and all that kind of stuff, I had to do research, and I used this. So I spent a little time researching, how do I do independent t-tests on this. So I would YouTube how to do that, and it showed me how to do it. It showed me how to enter the data, showed me go find the commands and all that kind of stuff, and it would run the data. But what it does is it just shows p-values. Excel shows both p-values and critical values, okay? Which is nice, okay? Does that make sense on how to use that? Okay. 10.1's open. It's not. I think I got the due date tomorrow. I'm flexible with that if we need to move it back. But I would like to go on to 10.2 tomorrow, which 10.2 is going to start talking about independent tests when you don't know the population standard deviation. So we'll use a t-test. All right. And as I work through Excel, it doesn't look like if we open that data analysis that I don't think it has independent t-test option. So we'll have to do that stuff by hand. All right. So these in Excel are kind of formed procedures. We can still do that. We can make our own. Okay, that would produce the exact same stuff, maybe even be more useful. But these preformed ones are nice for us.